Hey, today we're going through 5.2 in our Big Ideas book. Before we start that, I want you to review with your neighbor, remind them what a system of linear equations means, and then remind them what the solution of a system of linear equations is. Okay? Go back and review that real quick. All right, can someone remind me what a system of linear equations is? Keegan.
Two or more equations in a set.
Okay, two or more equations in a set. Okay, good. What's the solution of a system? Chelsea? Good, an ordered pair of two variables, that would be the solution of each equation. That would be in a system of two equations. Okay, good. So what we're going to do today is substitution. All right, on Friday we talked about graphing. Today we're dealing with substitution. Okay, and substitution, you got our three steps. Just like in graphing we had our steps, here's your steps here that you can go back and refer to. Solve one of the systems for one of the variables. In other words, it may help for you to think about it this way. Get a variable alone. Either get it into y equals form or get it into x equals form. Either one works. Okay. Number two, substitute the expression from step one to the other equation. Number three, solve it. So let's try some of these real quick. Here's what I want to do. Take a look at the next page, page 140. It says solve the system of linear equations by substitution, and then check your solution. Dude. So first thing you need to do, holy moly.
I got cut in the back of the leg with the skate.
That's some extreme skating there. I'm saying, sheesh. Oh, that was in hockey.
What?
Hockey.
Yeah.
Oh, okay. I thought maybe like skateboarding. It's like, holy cow. Pretty intense. Intense stuff. Okay. So the first thing I need you to do, taking a look at page 140. What I want you to just check out is make sure step one is true for each and every one of those equations on page 140. Everyone look at step one again. Solve one of the systems for one of the variables. So either have it in y equals or x equals. Okay, so one of our equations has to say y equals or x equals. Okay, so looking at 1 through 9, I want you to make sure that each of those equations has, or each of those systems has an equation that says y equals or x equals. If it does, you're good. If not, then circle the number, the problem number that you need to work with. We're completely good on that page. Is that what we're saying? Any that we're going to have to switch around? Yeah.
You look at
Number 6. Okay. So does number 6 have an x equals or a y equals? Yeah. Okay. Has a y equals. So you just want me to try number 6? Okay. Well, maybe that's one that we'll go through here. Okay. I want to go through number 1 first. All right. So all the other ones are good. Okay. Well, that's good. So step 1's done for all of those problems. Let's take a look at step 2. Step 2, substitute the expression from step 1 into the other equation and solve for one variable. Okay. Now the expression is this. If I zoom in on number 1, it says solve the system by substitution. Check our solution here. The expression you're substituting in here is, we now know what y equals. It has another name. We could call this equation, we could say it's y equals 5 minus x, or you could say 5 minus x is the same thing as y. This thing right here is the same as this thing right here. So wherever in this system, y equals 5 minus x. That means wherever you see y, rather than calling it y, you could call it this. Now the benefit of doing that is if I were to say, well, up here there's a y, and so that piece can plug in right there. The benefit of doing that is now I'd have one variable. So what I like to tell students to do is to circle what either your x equals or your y equals. So in this case, y equals this. So I circle this, and then I'm going to draw a line from that expression to where I'm going to put it in. I'm going to plug it in. Okay, it's like a socket here. This piece is going to go in right there. All right. So what I end up with after I do that, this top equation is going to change. It's now going to be 2x, stays the same, plus, that part stays the same. In fact, the 2 right there stays the same. And the equals, notice I put a big space here, and there's a reason for that. The equals 10 stays the same. The only piece that's going to change in that whole thing is that y right there. That y is no longer called y, it's called 5 minus x. Okay, is everyone with that? No, we didn't do anything major other than we plugged this piece where the y was. Okay, notice I used parentheses there. That's a big deal. When we substitute, you always want to put parentheses. Sometimes they'll make a big deal, a big difference. Sometimes they won't matter at all. It'll just show that you plug something in there. In this case, it makes a big difference. If I don't put it there, it looks like 25 minus x. Right? So what I've got here is now I have an equation I can solve. I have a single variable, the same variable x. Okay? I want everyone to solve that on your own, please.
Which kid? Okay.
2 times 5, my goodness. What ends up happening here? Hey, you get 10 equals 10. That's kind of weird, right? How many got 10 equals 10? Yeah, your x's cancel out. You get 2x minus 2x. Those are gone. You end up with 10 equals 10. That kind of makes it a tougher problem, right? With our variable gone. Really what that means when you're dealing with systems is it looks like this. This is, and I'm going to show you graphically. Now, all systems you can solve using a graph. Okay? I've changed my equations. My 5 minus x I've put into this form right here. I've just changed it up to slope-intercept. Okay? My 2x plus 2y equals 10 I've changed up to slope-intercept form. And now I've graphed that line down here, and now I'm going to end up graphing this line. You'll notice they're the exact same equation. So what points are these equations going to have in common? It's going to have every point in common. Okay? In fact, they're the exact same line. What's it mean if something's the exact same line? How many solutions will there be? Yeah. Yeah, there's an infinite number of solutions. So anytime you're solving with a graph and you get the exact same line, or if you're looking at a system and your variables disappear but you're left with a true statement, does 10 always equal 10? Yeah, it always equals 10. If it's a true statement, that's true, we say that's infinitely many. Infinitely many solutions. There's not one unique solution. There's an infinite number of solutions. So infinitely many. All right. Any questions there? Okay. Hey, let's try number 6. This is the one that Mr. Brendan wanted to try. Everyone give that one a go. Circle what you know, plug it in where you think it should go, and then solve the one equation. Give it a shot. All right, let's see here. Let's see if you did the same thing I did there. So I'm doing number 6, right? Just took your number 2. Skip down to number 6. It's all right though. You were good. You got a good start on number 2. All right. Hey, we got that circle. We plug it in for what, Jaden? For y, yeah. It goes right here. Now, will parentheses make a big difference on this one? Not really. The benefit for you as you progress in math, though, the parentheses will remind you that you did something there. Okay? So I'm going to put them there anyway. It just reminds me, hey, I plugged something in there. I replaced something. That way, if I have to look back at this problem later, maybe I missed something or I'm doing some kind of work with another type of problem, I'm using this information, and another problem I can remind myself I did something there. But really, when I go to solve it, they're not going to matter, right? There's nothing I bring in. Okay, I'm not distributing anything into the parentheses. Hey, how many got it that far? Okay, so how many x's on this side? 5. 5x's plus 5 equals negative 5. What's 5x equal? What do I do next? A minus 5, yeah. So 5x equals, I think Cole said it. What'd you say, Cole? Negative 10. Good. Don't make the mistake and accidentally put 0 there. Some students would do that. Okay? When you start going fast, divide both sides by 5, you get 1x's negative 2. How many got x equals negative 2? Good. If x equals negative 2, the next step is to substitute that into one of these equations to find y. Now, which one's the easier one to substitute x in to find y? Go ahead and tell your neighbor which one and why. No pun intended. Get that, right?
Why you say the second one? Why?
All right, which one? First or second? Looks like a lot of you saying 2. Why is it easier to put it in this one? Why? I get it. Yeah?
It's smaller.
Okay, maybe the numbers are smaller. Why else? Yeah, y is already by itself. You don't have to do much manipulation after you get it, right? So you have y equals 2 times x, which we know is going to be replaced with the negative 2, plus 5. Okay? So we plug that negative 2 in right here and solve it. We end up with y equals negative 4 plus 5, or y equals 1. So we have the ordered pair, negative 2, 1. All right. Tell your neighbor what that would look like graphically. Picture-wise, what would this system look like? Okay? Give it a go.
Would it be like a straight line since their y is both 1?
It wouldn't be a straight line. Yeah? It would be. Well, negative 2, 1 would be a point. Hey, guys, I automatically know that this line and this line will cross both x and y axes. It'll be a diagonal type of line because it has x and y in them. So I know it's going to cross both axes at some point. Okay? That's something I'm hoping you guys are picking up as we graph these, that if it has x and y, it's going to cross both. If it only has x, it's only going to cross x. Only has y, it's only going to cross y. But these are two kind of diagonal-esque lines like this, maybe. Okay? What is this point called? Right here, where they cross. Yeah. Yeah, it's called the intersection. So what's this intersection? Dude, I even have it labeled up there for you. Yeah, it's the intersection negative 2, 1. So what all this looks like graphically is two lines crossing at the ordered pair, negative 2, 1. That's it. Okay? I don't want you guys to lose track of what we did Friday. The picture form of this is just graphing these lines. Now we're showing you an algebraic way to solve these. Some students really like the graphing way. Some students really like the algebraic way. Substitution. Some like graphing. Some of you are going to really like elimination. Okay? Each one has their benefits. Okay. Any questions? All right, we're going to go about 10 minutes working on this page. Okay? Finishing our 1 through 9 here. Go for it. All right, so for those of you done with 1 through 3, here's the work for those. Try to zoom out there and just put those up there, and then I'll get the other ones up there here in a while, but just so you can kind of reference your work. There you go. Make sure you're asking for. Okay, so 4, 5, and 6. I know a lot of you are there, but real quick on number 3. Number 3. Some of you are struggling with this deal right here, seeing that x equals y. It seems to be a bit confusing for you. So on this one, if this one's confusing, you maybe skip it for now, but at least let me explain it a bit. In this case, we can either call x y, or we could call y x. Okay, just like I could call you by your first name or your last name. Okay, x has two names now. It has the name of y and it has the name of x. So we can call it either one. So wherever we see an x in this other problem, we could replace it with the letter y. And that's what I've done. I've said since x equals y, I'm going to replace the x up here with a y. Okay, so now rather than having x minus 3y equals negative 1, I have y minus 3y equals negative 1. Okay, combine like terms. This is 1y minus 3y is negative 2y. Divide both sides by negative 2, we get 1/2. Or you could have, if you wanted to, you could have put the x in for that y. But you ended up with getting the same thing. You would have got 1/2 as well. Okay, but if you're struggling with that, hopefully you skip down to the next one. So I'm going to put up 4, 5, and 6 just so you can see them real quick. Okay, we're gonna move on here in a minute. So I want you to make sure you at least can check through those three, and we're going to move on to the next part here. Okay, make sure you're asking if you need help, please. I've got the key for 7, 8, 9. I want you to finish those, but for now, I want you to go ahead and take a look at number 10 on the next page. Okay, 10, 11, 12. All right, so now going through this page, just like we did on the first page, remember our steps. Okay, the first step is to make sure that one of the equations, or solve one of the equations for one of the variables. So either get a y equals or x equals. So on number 10, is there a y equals or x equals in it? No. How about 11? Yeah, we're good here, right? In fact, they both have y equals, so you could just set this part equal to this part. So anytime, this is kind of like the other ones we have at the bottom of the first page. Anytime you have this, you have y equals and y equals, you just say this part equals that part. You just solve it like that. Okay? How about 12? Nope, you don't have a y equals or an x equals. So how about 13? Nope. 14? Yeah. 15? 16? Yep. 17? Nope. 18? Nope. So all these that we've circled here, we have to get x or y by itself. So now let's focus in on like number 10. Tell your neighbor which equation you're going to manipulate. You're going to move around pieces to get an x or y by itself. What's the easiest one to deal with? The top equation? Can we say the bottom equation? Why the top equation? Lily? It's simpler. Yeah, why is it simpler? Yeah, there's not a number in front of y or x. There's no coefficient. So really, I could either, what do we want to solve for, x or y? Who wants to solve for x? Like get x alone. Who wants to solve for y? Get y alone. Okay, let's solve for y. So what am I going to do to solve for y? I've got to subtract x on both sides. Okay, that's why we spend so much time on that. So y equals negative x plus 3. So now we have an x or y by itself. So I can take this and I can plug that in for, where do I plug it in? Okay.
Is it where the 8's at or the 4y?
It's one of those. Annalise? Yeah, I plug it in for the letter y. How many knew that? Sure. All right, some of us, yeah. Okay, so let's try it. I want you to go ahead and solve that one up there. All right, so I have 2x plus 4 Okay, and then y becomes negative x plus 3. And that's going to equal my 8. All right. So from there, I distribute this, right? Check it out. We get 2x minus 4x plus 12 equals 8. 2x minus 4x is negative 2x plus 12 equals 8. Negative 2x equals what? So I subtract 12, I get negative 4. So what's 1x? 1x is 2. All right. Okay. If x is 2, what's y? Well, we're going to plug it in. I can plug it in actually right back up into this equation. So we get y equals, I get my negative, and I put my 2 in, plus 3. So we actually get y equals y equals 1. Get the ordered pair, 2, 1. Okay, everyone rate themselves 1 to 5 right now. All right, your goal today is to finish up page 141. Okay? Do your best on number 19. I want you to try that story problem. It's the one we'll start with tomorrow. Okay? Try to get the 2 equations wrote out for number 19. Okay?